Hello Legacy Sabers, Marsh here. So today we're going to continue our graphing of linear functions. However, now we're going to look at two different forms or two different ways we can graph. One of them using x and y intercepts and one of them known as translated form. What you're going to want to have on you today, your notebook, a calculator, or a pen and a pencil as well. Learning targets. You need to determine the x and y intercepts of a linear function, graph a linear function using x and y intercepts, and then also graphing a linear function using translations of y equals x. So guys, let's remember back. When we had the equation y equals 6x plus 5, our slope was 6, and our y-intercept was this number right here, right? It was the point 0, 5, which ultimately we graphed right here. Then we went up 6, which would have been 11 over 1. And then I would go down 6 over 1 right here. Then we connected those dots, something like that, except you guys would connect much better than Miss Marsh. So what if, guys, what if this equation is not in the form y equals mx plus b? Do I have to rewrite that equation into that form, or can I graph using an easier way? Here's an example. 3x plus 2y equals 4. Ultimately, guys, I would have to subtract 3x, I would have to divide the 2. It's going to take me 10 times longer to be able to do it in y equals mx plus b form. Now, what if we would look at the x and y intercepts? Now, where are they on a graph? Well, x-intercepts are where they are crossing over the x-axis, right here. That is the x-intercept. The y-intercept is right here. What do we notice that's common between these 2 points? Well, they both have a 0 for a coordinate. Look at this one. This one has a coordinate of 1, 2, 3, 4, 5, 6, 0. And the y has a coordinate of 0, negative 4. Notice how the axis it crosses through is the number, but the other coordinate, the 0 or the x or the y, is a 0. That is what's common. That's what's going to help us. So we've already graphed using y equals mx plus b. Let's look at graphing with an intercept now. So, as we stated, just so you guys have a formal definition in your notes, the x-intercept is the point where a graph crosses your x-axis. How are you going to find it? Well, you're just going to make y equal to 0. So if you want to find the x-intercept, you need to make y equal to 0. I know it's kind of backwards, but kind of keep it straight in your mind. If I want to find where it crosses the x-axis at a number, your y is going to be 0. Y-intercept, same thing. It's where you cross the y-axis. To find that, you got to plug 0 in for x. You plot those 2 intercepts and away you go. You connect for your line. Let's try an example here. So I have 5x plus 2y equals 20. Let's find the x-intercept first. So off to the side here, so I kind of pay attention to my work, I'm going to put x-intercept. And I'm going to plug in 0 for y. Since I am finding the x-intercept, you're going to plug in 0 for y. So it's going to look something like this. 5x plus 2. Notice my y, 0 there, equals 20. Now, notice that's going to cross off. So I get 5x equals 20. If I solve for x here, divide by 5, I'll get x equals 4. Now, that is not a ordered pair. Please, please, please. This is something I'm a very big stickler about. This is not the x-intercept. That is a line. You need to write your x-intercept as an ordered pair. So, x is 4, y is 0. Okay, so this is the x-intercept. This is not. This is you solving for your x-intercept. Let's find the y-intercept now. Same process, except I'm not going to plug in for y this time. I'm going to plug in for x. So it's going to be 5 times, whoa, went a little further there, times 0 plus 2y equals 20. So I plugged in 0 for x. I got 5 times 0, gone. So I'm left at 2y equals 20. Divide by 2 on both sides. I get y equals 10. Again, guys, this is not the y-intercept. That is a line. So this is 0, 10 for my y-intercept. Now, I have found the two intercepts. Let's graph it. So 4, 0 right here. 0, 10 right there. Then if you had a straight edge or just a side of your paper, we are going to connect the dots to the best of our ability with a nice straight line. That's actually not too bad. It's kind of wobbly, but not bad. So I have now graphed the equation of 5x plus 2y equals 20. That would have taken a long time for me to graph it or to solve for y otherwise if I would have done it y equals mx plus b form. Let's try another example. I have the equation 4y equals 3x minus 9. Now, this one's a little more funky, but it's okay. Let's find our x-intercept first. So I'm going to plug in a 0 for your y. So I'm going to get 0 equals 3x minus 9, right? Need to get solve for x. So let's add 9. Divide by 3. So I get 3 equals x, right? So my x-intercept is the point 3, 0. Let's find our y-intercept now. 4y equals 3 times 0 minus 9. Because remember, if you're finding your y-intercept, you're plugging in 0 for your x. So I get the point 4y equals negative 9. I divide by 4 on both sides. We're going to get y equals negative 9/4. So my ordered pair would be 0, negative 9/4, which in my head I'm going to translate that to 2.25. So 2 1/4, negative 2 1/4. Let's graph those two ordered pairs. So I have the point 30 and negative 2.25. About right there. Whoops. Cross through. And done. Now imagine, guys, you would have divided by 4, right? So you would have 3/4 for a slope and negative 9/4 for a y-intercept. That would have been gross to count 3/4 up for your slope of 3 over 4. That would have been very difficult. This made it super simple to be able to graph. Now, what if your equation is still not in y equals mx plus b, or you can't find the intercepts as easily? So, do you have to write the equation in a different form? There is a different way to graph. So what if I had an equation that looks something like this? If I plug in a 0, it's going to not be too bad to find y, but if I plug in a 0 for y, that's going to be a little harder for us to find x, right? A little bit more manipulation. So, there's another way to sketch a graph for a line. It's called the translated form. Now, what does this mean? Using a translation of y equals x, that's when you just have a line that's going through 0, 0, right? That is y equals x. What this ultimately is doing, it is going to move the line right or left and then up or down, depending on where the point is. And the slope is going to basically act as like what you would consider an amplifier. It's going to stretch it or compress it further so it makes it a not as steep or a steeper line. How are you going to use this? Well, you're going to plot the point that's given in the equation, the h and the k. You're going to use your slope to find the second point, and you're going to connect them. Let's look at this before you start to go, whoa, I don't like it. So, let's use the translation form. I have y equals 2 times the quantity, x minus 3 plus 4. So let's plot the point. Now the point is this piece right here and this piece right here. This is the x value, this is your y value. Now, here is the problem, and here's kind of the kicker to this translated form. This is not, the x value is not negative 3. It is the opposite of what you see. So, normally, you would think that this would be negative 3. Your x value is actually going to be a positive 3. Notice in the form, it has a negative there. So, if there's not another negative, it's going to stay a negative. This, though, is going to be exactly as you see it. So if it's a positive 4, that means your y value is a positive 4. What is this actually going to do to your line? What is it going to do? It is going to take the point 0, 0 and move it to the point 3, 4. So 3, 4, graph that. And then it's going to use your slope or your amplifier to go further. So let's go up 2 over 1. Up 2 over 1. Up 2 over 1. Connect my line. Gold. Now, this is useful when we start to do what's called piecewise equations. That makes us graphing a line much easier and not as difficult as we continue along. Let's try one more example here. So I have y equals negative 2/3 quantity times the quantity of x plus 1 minus 2. So, where's my ordered pair? Remember, guys, opposite here. So it's going to be negative 1, negative 2 for an ordered pair. And then negative 2/3. So I'm going to go down to right 3. 1, 2, 3. And then to the best of my ability, I'm going to connect some dots. That is my line graphed with through the point negative 1, negative 2, and the slope negative 2/3. Now, coming soon, you're going to start being able to find x-intercepts of quadratic equations, which will be quite soon as we continue along our Algebra 2 journey. But in summary, you can use the point-slope form, or slope-intercept form, excuse me, where you have your intercept and you have the slope. You can use the intercept form when it looks something like 3x plus 2y equals 4. You can find an x-intercept, plug 0 in for y, y-intercept, plug 0 in for x, connect your intercepts, connect the line. Also, you can use your translated form of y equals m times the quantity x minus h plus k, plot the point, use the slope, connect the points for the line. That is the 3 different ways that you can graph a linear equation. And with that, that is the end of the video. See you later, Sabers.